Hello and welcome to another video, this time going through Matt Specimen A, Specimen Paper A, question 4. This is by request, somebody requested it, fantastic, I love requests. Apologies if I don't get round to them as quick as I can. I know somebody else recently requested me doing some question 6 and 7s from the Matt, which I've never done before, but I'd love to do actually, because I quite enjoy some of the logic ones for like the philosophy and computer science. They're quite good fun. I always worry though on those questions, exactly how they want me to set out my working. A bit like question 5 on this paper, which I'd love to get round to as well. Apologies that I haven't had as much time as normal. I've just been really busy at the start of the year and Ofsted are coming into my school and rah 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 rah. Anyway, enough excuses. Let's do it. So, when I think about this question, I thought the first bit is bog standard. Like the second bit's much harder, but it's not too bad though if you remain calm. Now, proving the area of a triangle and proving the sine rule, I think that should be shown to you by your A-level maths teacher, as they do area of a triangle and sine rule. I normally prove it to my year 11s when we get round to this bit, and this year I'll do the same thing. They'll probably hate me for it. I'll say you won't have to do it in the exam, but I like to show you why these things work, but it's good to see where they come from. So anyway, I'm just going to use the same approach as I do there. Now please, on this kind of question where the diagram is so useful, draw your diagram real clear, yeah? So I'm going to draw it like theirs, and I'm not going to put all the other lines on initially, because we're just proving that the area of a triangle which has sides A, B and C, and they're using alpha, beta and gamma for the opposite angles. So the sides are A, B and C, and they are here A, B and C, and then the angles are alpha and beta and gamma, yeah? Now, what do they want me to prove? They want me to prove that the area of this triangle is a half BC sine alpha. Yeah. So where I'm going to drop my perpendicular here is kind of like really important, like to prove this. I think it ends up being a little bit nicer if we use this line across here. Yeah. You just need to drop a perpendicular. This is a standard way of proving half AB sine C. So I'm just going to draw a line in. And what this line is going to represent is the perpendicular from that point up to there, yeah? And let's call this side H, yeah? And you might even want to write, using this diagram above. Let the examiner know what you're doing. Communicate with the examiner with words, yeah? Using this diagram above and drawing the line, and let me put some points on here because I do need those, C, A and B, and we'll call this R, yeah, and using the line RC, which is perpendicular to AB, the reason we have to do that, and it's perfectly okay if you start off on another line, but this is just standard proof of sine rule as far as I'm concerned. What we have to do is we can say the area of ABC is going to be equal to, well, it's just going to be a half times base times height. So it's going to be CH over 2, yeah? Nothing too controversial there. But we can also note that sine alpha, am I using sine of alpha? Is going to be equal to H over B. I've drawn this the wrong way around, have I? Have I just... Oh look, I've drawn 2 alphas. Sorry, I've just suddenly realised I've drawn 2 alphas there. That's a gamma, and that's why I was getting very confused here. I've got a really bad habit of mixing up my alphas and my gammas. It's a terrible habit because they just look so similar. But anyway, that's gamma. Now we can see that sine alpha, well, sine alpha is going to be opposite divided by hypotenuse. So it's going to be H over B. And I doubt you were stuck on this part of the question actually. And so we can see H is B sine alpha. And so we can pop that in there. And so hence, area of ABC is C times B sine alpha. Which is what they wanted, isn't it? They've written it as BC sine alpha, half BC sine alpha. Yeah? And then make it clear that that completes the proof. I've explained what I'm doing and I've made it very clear what's going on. That's always really, really useful, yeah? Okay, cool. And now they want to deduce the sine rule, yeah? Now, it's perfectly obvious from this diagram. We could have dropped our perpendiculars in other ways, or we could have just relabeled the triangle. In fact, it might be worth saying, with a simple relabeling of the triangle, we can see that, yeah, the area of ABC could be equal to a half BC sine A, sure, sine alpha, sorry, which is a half AB sine gamma, which is a half, which one haven't I done yet, AC sine beta, yeah? I hope they would just accept this argument, and the reason why the argument works is because I don't have to put C there. I could have put like B there and C over there, and then, you know, suddenly my A's and B's would switch round, because, I mean, what really is a half AB sine C or a half BC sine A? What is it really saying? It's saying you need two lengths and the angle in between them, you know, because here's B, here's C, here's the angle, to find the area of a triangle, and you just do a half times B times C times the sine of the angle between those two lengths. So it doesn't matter whether we start here, here, or here. We just need to make sure we're using the appropriate two sides and the angle in between. Yeah. Now, as soon as I've got that, I can just say, okay, so clearly we can cancel the halves. Yeah. Well, clearly we can see that if we just take the first two. Yeah. So BC sine alpha equals AB sine gamma. Yeah. We could cancel the B's, and we could then come up with C over sine gamma. Oh, look, I've written alpha again for gamma, equals A over sine alpha. Cool, yeah? And then using the last two, we can say AB, oh, not AS, but AB sine gamma equals AC sine beta. And so what I can do then, cancel the A's and say that B over sine beta equals C over sine gamma. And if C over sine gamma equals that and C over sine gamma equals this, we have the sine rule. Hence, we have the sine rule. Yeah, just convince the examiner you understand each step of the argument. A over sine alpha equals B over sine beta equals C over sine gamma. Colour in your little square. That completes the proof, yeah? Okay, so that's the first part done. That's, like I say, bog standard A level. Now, this was a little bit harder. I had to do a little bit of thinking about this. My thoughts when I got to this point were, how are we going to introduce cos? That was my main thing. How am I going to introduce cos? And I'll show you what I did. I'm not claiming that this is the easiest way. I'm just claiming, well, I'm certain as well that I would have done it a different way in my notes at school, because I've just basically, you know, done this as I was just putting my kids to bed and just, yeah, anyway, like I didn't have my original notes. This might be slightly longer than the way I did it at school, but I looked at this and I thought, well, particularly this diagram here, I thought the way I can relate PRQ to ABC is I can say, well, area of ABC minus area of APQ. Why am I capitalising that? Area of APQ, or PRQ, sorry. That's going to be equal to, you know, triangle BRP plus triangle ARQ plus triangle QPC. Yeah, that was my initial thought. Yeah, okay, I'm going to use that result, because if you look at this as well, right, you've got an area of PRQ here, you've got an area of ABC when you times that by the 1, and then you've got minus a load of things which are also being multiplied by ABC. So we've got an area of PQR and an area of ABC. Maybe these things will be representing the other triangles here, here, and here. That's what I thought. That was my thinking. Now, to do this, I actually relabeled it. I wrote down a lot of trig. Yeah, so let me make this a bit bigger. Try and make a really good diagram. This isn't a good example of a really good diagram. I don't think so anyway. A, B, C like that. Just checking the ordering. A, B, C. So this is little a. Let me just, yeah, little a, little b, little c. Then I did some stuff which you might not have been so happy with. A, this is a beta and gamma. Okay, so let me drop those perpendiculars like they do in their diagram. Yeah, and I'm going to do this in different colours, and I'm definitely going to tell the examiner what I'm doing. Sorry, I'm on a bit of a rant about kids not basically telling the marker what they're doing, because I've just marked some of my work, some tests from my students, and it's like often I get just these completely cryptic notes. I'm not brilliant on showing my working either, but you've got to give the marker a chance. You really have, and if they don't understand what you're doing, you're not going to get the marks. Okay, let's drop a perpendicular. Okay, this is going to be B1 and this is going to be B2. So I'm going to say, and we already know those letters. What are they? Q, P, and R. So this is Q. This is P. Where was P? And this is R. Okay. So just point out that AR equals C1. Let AR equals C1, RB equals C2. Naturally, C1 plus C2 is C. Likewise, AQ is going to be B1, QC is going to be B2. And lastly, BP is going to be A1 and PC is going to be A2. Okay, I used these values, yeah, and I thought I need to introduce some causes, and then I'm going to try and use this result and see if it works, yeah. So I was like, well, okay, what is cos beta? Yeah, now remember there's right angled triangles all over the shop here. Yeah, okay, what is cos of beta? Cos of beta, I could write that as this is A1 and that's the hypotenuse C, I noticed that cos beta was A1 over C. Yeah, I could also use cos beta. Well, I think what I did next, I did the A1 over C, and then I thought, well, I could also use, I can't remember where I started actually, let me just have a look at my notes. I thought cos gamma, yeah, that's right, I did it on the other side over here now with this triangle. I thought cos gamma is going to be A2 over B. Yeah. Now we can do this 4 more times, can't we? Because we can do it with each orientation. So now, looking at the right angled triangles on this side, I can say that let's take this cos alpha. I hope you can read that. That looks awful. Sorry, I wouldn't do that in an exam. I'm much neater, as I keep saying on these videos. I'm much neater when I do my written solutions. I'm very tempted to post up online my written solutions because I've got hundreds of step solutions which I haven't got near posting online. Hundreds and hundreds and hundreds, well, at least 100 solutions for step questions, possibly more. Okay, so anyway, let's do this. Cos alpha, similar thing. Cos alpha is going to be C1 over B. And cos, and I did C1 over B there. Let's do it on the other side now and say it's C2 over A, and that's cos beta equals C2 over A. Yeah, and this didn't take me too long. I know it looks like it's a bit of a, but it didn't take me too long to write these 6 results out. And then lastly, as we seem to be using different colours, lastly, if we look at, now I've looked at that right angle, I've looked at that right angle, so I'm going to look at this right angle now, and I'm going to say cos alpha is also B1 over C. Don't think I've done that one yet. And cos of what's next, cos of gamma equals B2 over A. Yeah, I actually wrote this down. I'm not saying this is the quickest way, not saying it, but I just needed to introduce some causes, yeah? Now, I thought, that's great, I've got that kind of thing, and then I thought, let's go back to this result which I'm going to use, which is area of the triangle ABC minus area of the triangle PRQ. This is basically this area minus the middle area is going to be equal to these 3 areas added together, yeah? Now, that's pretty easy to work out with your A1, A2, C1, C2, B1, B2, which is why I proceeded along these lines. So I said, okay, area of ABC minus area of PRQ is going to be equal to, okay, we need, if I can, I'm going to draw another picture. I'm going to take a picture of this diagram just so you can see what I'm doing. Let me just screenshot that. Okay, I hope this comes out all right on the video. It's just so I can you can easily see what I'm getting at. It's a very visual question, this kind of question. Okay, right. Now remember, oh, sorry, I've opened up LibreOffice. I didn't mean to do that. Let me just pull this up. We're dealing with here, if I can just annotate this on a diagram, that's A1, that's A2, that's C2, that's C1, that's B1, that's B2, yeah? Bear that in mind because that's going to come in really useful for the next bit. So area of ABC minus RPQ is going to be these three triangles here. That's going to be equal to a half. Now I'm just going to use half AB sine C for this, you know, that kind of technique. And I'm going to factorise out the halves because why not? Oh, actually, no, I might not, actually, because it's not that useful. Okay, half A1C2 sine beta plus a half A2B2 sine gamma plus a half C1B1 sine alpha. Yeah? Cool, I've got that, yeah, and I thought, okay, can I introduce some causes here and try and get rid of my sines? That's what I thought. So I introduced the causes, and I noticed that A1C2, look here, A1C2, let's see where I've got those, let's get my highlighter pen out. A1 and C2, I'm going to use these two results, because that's got an A1 in it, and that's got a C2 in it, and I'm going to immediately rewrite this, oh, if I get my pen back, as a half. Right, A1 C2, can you see that would be AC cos squared beta? Yeah, because A1 is C cos beta and C2 is A cos beta, so A1 C2 will be C cos beta times A cos beta, which is AC cos squared beta. And then we've got a sine beta on the end. And I did exactly the same trick here. A2 B2, well, that's these two formulas, so I need AB cos squared gamma, and I started getting excited because I thought, oh, it's always working out nicely. AB cos squared gamma, and then lastly I've got a half, and I used these last two, B1 and C1. You can see there that's going to be BC cos squared alpha. Oh, I forgot the, look at that, I've made a little mistake there. That needs a sine gamma on the end. And then I've got a half B1 C1, which is BC cos squared alpha. And then I've got a sine alpha on the end, yeah? And I thought, oh, that looks a little bit bad. But then I thought, no, actually it leads directly to the answer. I was a little bit worried at first, but then I had a good look and thought, no, this gives me the answer. Because, don't forget, what is a half AC sine beta? We wrote it down earlier. A half AC sine beta, where is it? Oh, it's area of ABC. What's a half AB sine gamma? It's area of ABC. What's a half BC sine alpha? It's area of ABC. That's exactly what we've got here, here, and here, if you ignore the cos squareds. In other words, yeah, this is equal to, well, let's just write it down like this and factorise it out, because that bit of the term, that bit of the term, and that bit of the term, they're all areas of ABC. So you can factorise it out and just say this is equal to area of ABC times cos squared beta plus cos squared gamma plus cos squared alpha. Yeah, lovely. And now this easily rearranges into the result. Keep writing down the left hand side. My students get lazy and never want to, and then wonder why they're confused. You know, I do feel their pain as well. I hate writing down loads of algebra, but you just have to in these questions. If you don't like writing down loads of algebra, don't do maths at uni. Do yourself a favour. Okay, add this onto this side, take that over there. You're going to get essentially the answer, area of ABC multiplied by 1 minus cos squared alpha minus cos squared gamma minus cos squared beta equals area of PRQ. And that's how I did it tonight anyway, when I was sat at the kitchen table after I put the kids to bed. Is it the best way? I don't think so, probably not. I'll have a look tomorrow. I'm quite intrigued as to how I did it before. Okay, this last part is quite interesting. I had to use sort of like a bit more visual imagination for this, yeah? When does this hold? Well, you can see straight away that if that was true, this formula ends up being 0. So area of PQR must be 0, yeah? So that doesn't mean, by the way, that area of ABC is 0. Yeah, this might, this is where people can make logical fallacies. Yeah. If this bit equals 1, then this is equal to 0. Now you might think, oh, that means area of ABC is 0, because look, we've got ABC times something, uh, no, yeah, this is already 0. Absolutely not. And if you were to rearrange this, you'll have 0 divided by 0, and so you can't make any conclusions from that. Yeah, you can't draw any conclusions from that. It's an indeterminate form. We're not saying the area of ABC is 0, we're just saying the area of PQR is 0, yeah? So how do we get PQR 0? So area of PQR is 0. Now this is only possible, and I had to think about the points moving around here, around the diagram, yeah? How are we going to get, the area being 0? Well, if you think about it, yeah, if you've ever got P basically mapping onto the same point as R. Imagine this sliding down in that direction, this sliding back in that direction. How would that slide back in that direction? Well, if this point slides back, so it's perpendicular with B. That's how you get that one moving in that direction. How do you get that moving in that direction? Well, once again, if this point slides down, yeah, if that moves back there, then the perpendicular distance from C to B will be at B, and so R will be on B and P will be on B. In other words, it's when you got a right angled triangle, yeah, that you're going to get R over here and P over here, because they were defined to be just a perpendicular distance from this line up to this point. In other words, the shortest distance from a point to a line, shortest distance from a point to a line. So R and P are coincident then. And at that point, when you've got one point coincident with another on a triangle, that's called a degenerate triangle. It means it's basically degenerated into a flat thing. Yeah, it sounds like something out of Goodfellas. I know what you mean, like a degenerate gamblers, but no, it's a degenerate triangle. It's collapsed in on itself and its area is 0. So that's going to happen when you've got a right angled triangle. I'm slightly worried about whether there'd be some other cases where you'd have that happening, but I couldn't see them, so I don't know, what sort of marks I get for my justification. So I'd say this occurs when P, Q, or R, when, how to put this precisely, when a pair from P, Q, and R, a pair of the points from P, Q, and R are in the same place. I think the correct way to say it is coincident. Yeah. When this occurs, it must be a right angled triangle. I immediately as well looked at it algebraically and thought, yeah, no, that must be right, because like when this is true, yeah, well, I thought, well, I've said it's got to be a right angled triangle, and then one of these angles will be 90, yeah? And what is cos of 90? It's 0. So one of these will go, and then you're going to have cos squared alpha plus cos squared beta equals 1. Now, is that always the case for a right angled triangle? Yeah, for what, I just suddenly, it suddenly reminded me of Pythagoras, and I thought, I'm certain I'm picking up on just a Pythagoras' theorem thing here. Like, what is cos squared alpha if we have it as, if we call this x, y, and z, like cos squared alpha here is just obviously adjacent divided by hypotenuse squared. I'm just getting Pythagoras' theorem from this result, I feel like. I really am. And I was thinking, could you have worked it out algebraically just by thinking, well, if that's true, one of these must be 0. Basically, you're going to get Pythagoras' theorem out of this now, I think, because you're going to have y squared over z squared here. You're going to have cos squared beta. Well, that's going to be x squared over z squared. Yeah, and so you're going to end up with x, that plus that equals 1 times through by z squared. You get x squared plus y squared is z squared. So you got Pythagoras, So yeah, that occurred to me at the end and made me sort of chuckle and sort of like appreciate the beauty in it. But yeah, hope that was useful anyway to you. Yeah, I'll keep trying to do these videos. I must admit, I have a preference for step over mat. I don't know what it is. Maybe it's because I just started doing step way before I did any mat questions. I was unfamiliar with a mat for a long time, to be honest. There's something about the step. the questions just charming. They really are. But I'm not saying there's anything negative about the Matt. I really enjoyed the Matt question 2. I think from last year. This year's, the most recent one. I thought that was a wicked number theory question. But I tend to prefer. I'm not saying I'm better at it, 'cause steps blimmin' hard, but I just like the step questions. I like the way they're asked. Anyway, bye bye. Have a lovely evening.